Mr. Karthik,
Yes, sir.
in today's class, I will show you how a main voltage will convert to less voltage. Means it's a buck converter, how it will work. So usually what voltage in the motherboard goes? What voltage?
19.5
19.5 volts, right? So in 3 volt section and 5 volt section, how it will convert
Okay.
19 to 3 volts? Through the DSO, help of DSO, I will show you.
Okay,
So first, what we will do, what are the basic voltages? Actually, in voltage, you already checked all the things, right? Continuity part, you checked. Now, the supply part, I will give and I will show you. What are the supply part? What are the B plus and where it will go to as input like that. Okay, those things I will show you first. Then how buck converter will work. So, shall we check?
Okay, sir.
Okay, one by one we will check. So in S5 stage, so what are the voltage will be there? Main voltage?
Sir, 19.5,
Okay.
3.3 VL,
Hmm.
3.3 always,
Okay.
5 volt VL,
Hmm.
P, 5 volt always,
Hmm.
1.8 volt
Hmm.
always, 1 volt always,
Hmm.
3.3 always SOC.
Okay. So now first we will check that B plus 3 volts always, 5 volts always, 1.8 volt always, 1 volts always. And then we will check what are the buck converter, what input it will take and what output it gives. Okay. So now the DC jack. Right. Now I connected the DC supply. Here is the DC jack. What the voltage you check? I kept here 5 volts per box in DSO. Now the input section. What are the voltage? 19.73. Right. This is the maximum. Exact voltage is 19.63. Then it comes to the first MOSFET. First MOSFET where it's a drain. Right.
Yes.
Drain it came 90.63.
63.
So after that it got gate voltage. What is the voltage? 4.7.
7.
As per the average we calculated, right?
Yes, sir.
So now source will start working. So complete voltage from drain to source it will come. Correct.
Okay.
So next that source is connected to other source, but the gate, other second MOSFET gate, same 4.7. Then the output, the source, it has connected to the source, right? It's input of second MOSFET. So that also having same 19.6. Then the output of the second MOSFET 19.63. Okay. Next the CLR output. So we will take it in PJ. What is that? 301 jumper. Through this jumper all over the motherboard supply goes. So mainly this B plus will goes to the input section of 3 volts and input section of 5 volts. So now here it's a B plus. What are the input section of 3 volts that you check? That you check?
Yes, sir.
Which one?
PJ 404.
PJ 404 is the input. Completely you check. PJ 404. See, that is the output actually. So what about input? PJ 401.
401.
See the B plus voltage. Correct, 19.73. Now input got 19.73, but it converted to 3 volts always. Okay, how I will show in the DSO. Now this is the input. Now I will check the output. What the output?
PJ
Number?
402.
PJ 402. See here 3.3 straight line. Correct. So it's a pure DC. Maybe distortion is showing here, but it's a pure DC.
Sir.
Now I will show you once this particular IC gets the enable signal, what is that, ECN and B plus, then it will convert internally 3 volts always and 3 volts VL. Now 3 volts VL is the first voltage, right?
Yes.
What is the section? It's a PJ 404, I think so. See 3 volts we got 3.3 volts. This is VL. Now the output section is pure DC. It's a 3.3 volts always. Now this before coil, the before coil will be sinusoidal and finally it will come to straight line. So it means sinusoidal means some of the time period, the PWM section I told you, right? Some of the time period it will be on, which one? First MOSFET. And after some times it will be off. Again it will be on and again it will be off. It means it's a switching options. I mean switching process will be there. So due to that switching process, you will get the 3 volts always from the 19 voltage. Okay, that one we need to check before this coil. See here, here is the process. See here, actually straight line it has started from here.
Okay,
But negative term also is there. See the length, what it's showing actually is the maximum voltage, 20 volts.
20 volts.
But what about output?
3.3
volts. How? See, this length is 20 volts. So I told you know, some of the time high MOSFET will be high and some of the time low MOSFET will be on, and then this kind of sinusoidal will generate and finally this output you will get.
Okay, sir.
Maximum is 20 volts, so finally minimum you will get 3.3 volts.
3.3.
Same thing all buck converter will do. Okay, for example, charging IC I will show you. It doesn't have high-low MOSFET. In charging IC, we will check. Okay, charging IC gate voltage and the output voltage. See, the charging IC where it is here.
Yes, sir.
What is the high-low MOSFET? High MOSFET, which one?
I MOSFET PQ311.
PQ311 is here. Okay.
Okay, sir.
The gate voltage I will check. What is the pin number? Just a minute. Here is the 1, 2, 3. This is the gate. See, gate won't show properly. Maximum it's showing 1.7.
Okay, sir.
Somehow, some of the time period it will be on and some of the time period it won't be on. But here we are getting it's a 1.7 volts gate voltage. But what about source? See, it's a battery voltage. So battery is not connected. Sometimes we will get the voltage, sometimes we won't. Battery output 1.7 volts.
1.7.
Okay. So input is 19.5. Okay. Here once we connect the battery, then we get the final output. But here sinusoidal output not there. See the coil output, coil input. Okay, we not connected the charger, so then it's okay, no issues. But now I will show you in other buck converters. Here what we are getting in 5 section,
5.
input
19.
Output 5 volts. How it come? In between, before the coil we need to check. See, before the coil I am going to check. This one is boost capacitor, and after the boost the output you will get. In coil only I will show you. See, what is the input? This IC got 20.5 volts, correct?
Yes, sir.
What is the output? 5 volts.
5 volts.
So this is the process. High, low, high, low, high, low. Some of the time period it will be on, some of the time period it will be off, on, off, on, off, on, off. Average output you will get as a 5 volts. Same 3 volts also. See, as per the input only it gives the output, no other voltage. Okay, depends on input, it gives the output. Okay, in case of 1.8 and 1.0, that we will check. In 1.8, what input you will get?
Input 3 volts.
Where is that?
PJ601.
PJ601. PJ601. That is the input, right?
Yes.
Input, what is the voltage?
3 volt always.
It means we have to get the 3 volt as the input and output 1.8 or 1? 1.8. Right. So that also I will show you how it will come. It will convert. See, here PL601. PL601 input section I am telling. Input in the sense it's output section. Coil input side. See what I told, what it will get the input that it will show. Maximum what is the 3.3 it got, right? 3.3. Here I will reduce little bit, then you come to know the size. See, on positive, negative, high, low process happened, and finally you got the 1.8 voltage. Correct?
Correct.
So as per the input, the buck converter will work. And one more voltage, what is that?
1 volt.
1 volts. What is the input?
Input 5 volts.
5 volts.
PJ701.
PJ701. It's a 702. PJ701. What is the input? 5 volts. Correct. 5 volts input. And what will be the output?
1 volt.
1 volts. What is the
PJ702.
okay, PJ702. We are getting 1 volts. Correct.
Correct.
Now, how it converted? That before the coil we will check. See, before the coil, this is the process. Properly I will keep. Okay, what is the length of this? 5 point something, 5.1. It means it's a 5 volts converting as 1 volts.
1 volts.
Now you come to know. Correct?
Correct.
This is the process how a buck converter will work in any laptops. Okay?
Sir.
Now you understood the main voltage concept.
Yes, sir.
In next section, you come to know what are the signals and what are the enable signals and what are the communication channels.
Okay, sir.
Okay, now you completely understood the main voltage concept, how it will convert from 19 to 3 or particular sections voltage. Okay,
sir.
that's it. Thank you very much.
Thank you, sir.